guys, welcome back to my YouTube channel. Today I am going to solve day 19 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. So today I am going to solve problem number 3068. Find the maximum sum of node values. Okay, so this question is marked as hard by LeetCode. But don't worry, by the end of this video you guys will find this problem as very easy. Okay, so now let's read the problem statement first. Okay, so in this problem we have given an undirected tree with n nodes numbered from 0 to n minus 1. Okay, so here let's suppose that this is one tree. Okay, this is one node and this node's value is 0, and this node is connected with this node and this node's value is 1. Okay, so see here, by undirected we mean that from 0 we can go to 1 and from 1 we can go to 0. Okay, this is the meaning of undirected. Okay, and in this particular example, see, there are total 2 number of nodes, right? So, and how nodes we have numbered the nodes? We have numbered the nodes from 0 to n minus 1. Okay, so 0 and n minus 1 is 2 minus 1, 1. Okay, I hope that this is clear. Then you are given a 0 index 2D integer array edges of length n minus 1. Okay, where edges u and v indicates that there is an edge between node u and v in the tree. Okay, so let's take this as u and this is v. Okay, so here see, if total number of nodes is equal to 2, then how many edges are there? Edges are there n minus 1, right? So yeah, that's it. So see here, 2 nodes are there and just one edge in between, right? You are also given a positive integer k and a 0 indexed array of non-negative integers nums of length n, where num I represents the value of the nodes numbered I. Okay, so here Alice wants the sum of values of tree nodes to be maximum, for which Alice can perform the following operation any number of times, including 0 on the tree. So these two operations. So what are the operations here? So choose any edge connecting the nodes u and v and update their values as follows. Okay, so this is a tree, right? This is a tree given to us. Let's take it. It has a node 0. This is node 1. This is node 1 and this is node 2. Okay, here I am talking about the indexes. Okay, this is node index 0, node index 0, this is node index 1, node index 2. Okay, and we are also filling the values. Okay, so here 0th index value is 1. Okay, so here let's fill the value. Okay, let's fill the value. All right. Okay, so now here what I'm going to do here, this is my nums arena. So this is this node index is 0, this node index is 1 and this node index is 2. Okay, so in node index 0 I am filling 1, in node index 1 I am filling 2, and in node index 2 I am filling 1. Okay, now I am writing node values in between. Okay, so these are nothing but indexes, these are nothing but node indexes. Initially we have given the node indexes here. Okay, so this is clear, right? So here I have filled the values. Okay, so here in green color icon I am going to write the indexes. This is 0th index, this is first index, and this is second index. Okay, so now what we can do here, so there is one edge. Okay, so let's take this example. Okay, 0 to 1 there is one edge, right? So 0th index and 1 index there is one edge. Okay, so what we can do here, what are the operations that we are going to perform here? Okay, so I am considering this edge. Okay, so I am going to update this value as 1 XOR k. What is the value of k? 3. So what is the value of 1 XOR 3? Okay, so how I am going to write 1? So 1 I am going to write like this, 0 0 1, and how I am going to write 3? I am going to write 3 as like this. Okay, So if I'm going to do the XOR of these two numbers, then what is my output? My output is 2, right? This is my output. Okay, so this is how I am writing the numbers in bits now, right? 1 2 4. Okay, so this is how I am representing the 1. This is how I am representing 3, right? And I am doing the XOR, and this is my output. My output result is nothing but 2. Okay, so if I do the XOR of 1 with 3, then I am getting the output as 2, right? And see here, we are updating the values. Okay, we are applying the XOR in pairs every time. Okay, so you and we both are connected, and okay, both are connected, so we have to do the XOR on both of them. Okay, so here, what is the value of 2 XOR 3? What is the value of 2 XOR 3 here? So value of 2 XOR 3 is 2 XOR 3. Okay, same way we have to calculate. So here I am going to write 2, second number is 3. Okay, so what is my XOR result? XOR value is 1. Okay, so I am getting the XOR value as 1. Okay, if I do the 2 XOR 3, okay, then I am getting the output as 1. Okay, I hope that this is clear. Okay, if I perform the XOR operation, then this is what I am getting. Okay, but here see, we have to return the maximum possible sum of the values a slice can achieve by performing the operation any number of times. Okay, maximum possible sum. But here, if I am performing the XOR of this 2 with 3, then I am decrementing the value of this node, okay, from 2 to 1. Okay, so this is not a right thing, right? This is not the right thing. Okay, so let's not perform the XOR operation on this edge. Okay, let's not perform the XOR operation on this edge. Okay, so now see here, let's perform the XOR operation on this edge. Okay, so if I perform XOR, okay, so there is one edge, right? From 0 to 2 there is one edge. Okay, from 0 to 2 there is one edge. Okay, so let's perform the XOR operation here. So if I XOR this 1 with my k, then what is the result that I am going to get? I am going to get 2. Okay, and here this node value is also 1. And if I am going to perform the XOR of this 1 with 3, then again I am going to get the output as 2, right? So here, see, in both these cases, okay, u value is also updated and v values are also updated. Okay, I am going to perform the XOR, right? Okay, I am not considering this edge. I am not considering this. I am not considering this. Okay, I am just doing the XOR of this edge. Okay, in pairs. Okay, I have to do the XOR in pairs. Okay, so if I am going to do the XOR, then this one is updated to 2 and this one is updated to 2. Okay, so now initially my nums array is looking like this: 1, 2 and 1. Okay, this is nothing but 0th index. This is first index. This is second index, right? Index. This is second index, right? So now after updating, so now my 0th index, okay, this is my 0th index. 0th index, it becomes 2. There is no change in my first index. This is my first index, right? This is my first index. So in my first index there is no change. So here I am writing 2. In second index, this is my second index, right? In my second index, 1 is updated to 2. Okay, so what is the output that I am going to get here? 2 plus 2 plus 2 is, okay, I have to just perform the addition now. I have to return the maximum possible sum. So I am going to get the output as 6. Okay, so see here, my output is 6. Okay, so I hope that you guys are clear what we are doing here. Okay, so now let's discuss the approach that we are going to use to solve this problem. Okay, so can I do here one thing? Okay, so this is my nums array. Okay, this is my nums array. Okay, nums array 1, 2 and 1. Okay, this is my nums array. Okay, if I perform the XOR, okay, so this is basic process, okay, which everyone is going to think. Okay, all the beginners will think about this approach. Okay, so but they will think that if I perform the XOR of any number with k, if I get the maximum number, then I have to consider that number, otherwise I have to just ignore that number. Okay, so if I do the XOR of this 1 with 3, then I'm going to get the output as 2. right, and 2 is greater than 1. Okay, so here I am going to write 2. If I do the XOR of this 2 with my k, then I am going to get the output as 1. Okay, okay, so 1 is less than 2. Okay, so I am not going to do anything. Okay, so here I am not going to do anything. Okay, so I am just going to write original number 2. Okay, if I am going to perform the XOR of this 1 with 3, then I am going to get the output as 2. Okay, and this 2 is greater than 1. Okay, so I am going to write 2 here, and in the end we are going to perform the addition and we are going to get the result 6. Okay, this is the first thing that comes into the mind. Okay, let's do like this. Okay, but now let's consider this case. Okay, let's consider this case. Okay, this is my 0th index, this is my 1 index, this is my 2 index. Okay, now what I'm saying here, let's suppose that this time this node value is 2, this node value is 1, and this node value is 1. Okay, so now tell me, okay, so let's do one thing here. Okay, let's perform the XOR operation for this edge. Okay, we have to perform the XOR in edges, right? So if I perform the k is 3, okay, let's take my k value as 3. Okay, so 2 XOR 3 value, what is a 2? Okay, so let's write the number first. Okay, so this is how it looks like. My 0th index, 2 values there, nums array. Okay, and in my 1 index, 1 values there, and in my 2nd index, 1 value is there. Okay, this is my nums array. Okay, for this particular example. Okay, now I am talking about this particular example. Okay, so let's perform the XOR of this 2 with 3. Then what is the output I am going to get? I am going to get the output as 1. Okay, and this one is smaller than 2, so I don't need to write. Okay, so here I'm just writing the original number 2. And if I perform the XOR of this one with my k value is 3, right, then I'm going to get the output as 2, right? So I'm going to write here 2. Here if I'm going to write I'm going to do XOR of this one with my k value, that is 1 XOR 3, then I'm going to get output as 2. So I'm going to get total output as 6. Okay, this is what I am expecting. Okay, and this could be the right answer. This could be the right answer for this particular example, but let's see how. Okay, so now if I did the XOR of this number 1, and so I am going to get the output as 2. Okay, okay, so here in this pencil I am going to do the XOR of 1 with 3. Okay, and I am going to get the output as 2. Okay, and also I have to perform the XOR of 2 with 3, but this time this value is decrementing, right? This value is decrementing, right? So if I do the 2 XOR 3, I am getting the output as 1. Okay, this value is decrementing. Okay, now so, and this 1 is not connected with 1. Okay, so we can't simply write this 1 and 1. Okay, so see here, there is no direct connection between this 1 and 1 adjacent. Both ones are not adjacent right now. Okay, but how we are getting the answer as 6? Okay, so see here, one time I perform the XOR between this one and this 2. Okay, in this edge. Okay, so I am going to get the output as 2 here, and here what is the output that I am getting? 2 XOR 3, I am getting the output as 1, right? 2 XOR 3 is 1. Okay, next time let's perform the XOR of this one as well. Okay, let's perform the XOR for this edge as well. So this one will become 1 XOR 3, and I am going to get the output as 2. And here again I am performing the XOR. Okay, so 2 XOR 3, again XOR 3. So here my result will become 2. Why this will become 2? Okay, this will return to its original form. Why? Because XOR of any two similar numbers is always 0. Okay, they will cancel out each other. Okay, so this is XOR table, right? This is my XOR table. Okay, if one value is 0 and other value is also 0, then I have to return 0 only. If one value is 1 and other value is 1, then I have to return 0 only. If one value is 0 and one value is a 1, then in that case I have to return 1. Okay, so this is my XOR table, right? So if I do the XOR of same number, okay, then I will always get the output as 0. Okay, so see here, if I do the 2 XOR 2, then what is the value I'm getting? 0. If I do the XOR of 3 with 3, what is the value I'm getting? 0. If I'm going to do the XOR of 1 with 1, then what is the value I'm going to get? 0. Okay, if I'm going to do the XOR of 1 and 0, 1 and 0, then see, then we are getting 1. But if I'm going to do the XOR with the same number, then I'm going to get the 0. Okay, so this is the basic formulas, right? Basic operation for the XORs, right? So see here, 2 XOR 3 cancelling out becomes 2. And now let's do the sum. So now the sum is correct. We are getting the output as 6. Okay, but this will always work? No. Okay, so let's now go to the second case. Okay, so this is the first case. Okay, this is the first case. In this we are just doing the XOR for this edge 0 to 2. Okay, just one for one edge we are doing the XOR and we are getting the max output. Here in this case I am doing the XOR for the two edges, one for this one and then for this one, and then I am getting the max result. Okay, so here from here one more thing is clear. Okay, one more thing is clear. Okay, see here, I am performing the XOR now. I am performing the XOR. So see here, for this node, okay, let's say that this is my U and this is my V. Okay, this is my U and this is V. Okay, edges U and V. Okay, so U and V both are connected indirectly, right? See here, this edge is connected with this edge, right? But in between there are some edges. But see, but they are connected. But they are always connected. Okay, in a tree they are always connected. Okay, so let's say this is my U and this is my V. Okay, so I have to apply the XOR. For this U and V. Okay, so let's do one thing here. Let's apply the XOR. Okay, let's name it as P1. Let's name it as P2. Let's name it as P3. Okay, so U and V are connected. Okay, so indirectly they are connected. Okay, so see here, 1 2 1. Okay, I'm talking about the node values. 1 value, node value, 2 node value, 1 value. Okay, this 1 index is connected with 0 and 0 is connected with 2. There is one connection, right, from 1 to 2. So if I perform the XOR of this U with P1, okay, for this particular edge, then this value become U XOR K and this value will become P1 XOR K. Okay, now if I perform the XOR between these two edge P1 and P2, then this value will become P1 XOR K. Okay, and this value will become P2 XOR K. Okay, now if I perform the XOR between P2 and P3, then P2 XOR K. Okay, it will look like this, and P3 will become P3 XOR K, right? If I perform the XOR between P3 and this V, then P3 XOR K and V XOR K. So see here one important pattern, that in between we are just cancelling out everything. There is no change in the nodes from P1 to P3. There is no change. Okay, we are cancelling out. In U and V only we are making the changes, right? In U and V only we are doing the XOR, right? So I hope that this thing is clear. Okay, they are all cancelling out with each other. Okay, all the edges are cancelling out with each other. Okay, because we know that A XOR B is always A, right? That P1 XOR K is always P1, because these are cancelling out. Okay, so we can perform the XOR between this U and between this B. Okay, we are going to treat them as connected only. Okay, because in between, see, there is no change. Okay, so I hope that this line is clear. Okay, so here see, I am performing the XOR. Okay, indirectly I am going to say that I am going to perform the XOR of 1 with 3, and for this node index 4 at index 2 I am performing the XOR of 1 with 3. Okay, and for this there is no impact. Okay, I am retaining its original form. Okay, by doing the XOR 2 times. Okay, for between this edge and between this edge, 2 XOR 3, XOR 3 is nothing but 2. Okay, so yeah, we are good. We didn't perform any change in this one, and we have changed this 1 to 2, we have changed this 1 to 2, and our output is 6. Okay, now let's move to the case 3. Okay, let's move to the case 3. Case 3. Okay, so let's this is my node at index 0, this is my node at index 1, and this is my node at index 2. Okay, so now let's fill the value. Okay, let's say that let's say that this node value is 2, this node value is 2, and this node value is 1. Okay, now in this case, if I'm going to write this in my nums array, then I'm going to write it like this: 1, 2, and 2. Okay, I'm going to write it in nums array. Okay, my k is 3, same, k is equal to 3 in this case as well. Okay, so now let's perform the 1 XOR with k. So 1 XOR k is nothing but 1 XOR 3 is nothing but 2. And what is the value of 2 XOR 3? What is the value of 2 XOR 3? 2 XOR 3 value is 1. Okay, so we are just going to write the original value here, 2. What is the XOR of this 2 with 3? 2 XOR 3 is nothing but 1. Okay, so we are going to get the output, write it as 2 only. Okay, see here, this is giving me output as 6. This is giving me the output as 6, but this 6 is the right? No. Why this 6 is not right? So let's see. Okay, let's see. See here, for this particular node only value is incrementing. For this particular node only value is incrementing. Okay, only for this only particular node our value is increased, and for all other nodes value is not increased. For just one, okay, we are applying the XOR operation in just one node. But is this possible? Tell me, is this possible? We are just performing the XOR on just one node. Okay, but see here in the problem statement, we are performing the XOR in pairs. We are performing the XOR in pairs. But here in case 3, okay, if I take this example, if I just perform the XOR on this one, and for others I am cancelling out the XOR. Okay, I am just performing the XOR on this particular number. Then is this a correct thing? No, this is not correct thing. Okay, so let's see this with example. Okay, so for this 2, okay, this is let's perform the XOR for this particular edge. Okay, so this number will become 2 XOR 3, this number will become 1, and if I perform the XOR for this one, then this number will become 1 XOR 3 is equal to 2. Okay, okay, this is one thing. But here see, value is decrementing for this one, value is decrementing, right? Value is decrementing for this one. Now if I perform the XOR for this edge, okay, then this number will become latest value is 2 now. Latest value is 2. 2 XOR 3 is 1, and for this number will also become 2 XOR 3 is equal to 1. So this is not the best case. Okay, I can't perform XOR 2 times, because if I perform XOR 2 times, then the value is decrementing. Okay, I am performing the XOR, right? I am performing the XOR for this edge and then for this edge. Okay, in pairs. Okay, so if I perform the XOR in pairs, this latest value, okay, original value is like this: 1 2 2 0 index, 1 index, second index. Okay, so if I do the XOR for both edges, for two edges, then my numbers in the ends are looking like this. Okay, so at 0th index it is going to retain its original form, and this is becoming 1 1 1. So in this I am getting the sum as 3. In the original form I am getting the sum as 5. In the original form I am getting the sum as 5, right? So I can't perform XOR just one time. I can't perform the XOR on just one node. Okay, here see, I am, when I am performing the XOR in this edge, then I am performing the XOR on these two nodes. When I am performing the XOR on this edge, I am performing the XOR on these two nodes. Okay, so in total 4 times, na? In total, first time this node changed, and then this node change. Okay, then after time when I perform the XOR for this particular edge, then again this node changes. Okay, then this node changes. So total four time nodes are changes, right? Four time nodes are changing, right? So I can't just perform the XOR on just particular node. Okay, so from here one thing is clear, that we need even number of XOR benefit nodes. Okay, so see here, right? Agree with this statement? Okay, so here we are just performing the XOR on one node. Okay, and this is not a good case. Okay, so we are getting the output as 6, but what is the output that we should get? We should get the output as 5, not 6. Okay, so what should we need to do in this case? Okay, what should we need to do in this particular case? Okay, so see here, this is the my original nums array 1 2 2, and after modifying, okay, this is my original. Okay, in original I am getting the sum as 5. Okay, see in this box, this is my original, and in this original 1 2 2 I am getting the sum as 5. Okay, when I am performing the XOR, then I am getting nodes value as 2 2 2, and I am getting the sum as 6. But here, since only for one node we are performing the XOR, so we know that this is not the correct case. Okay, because we need the pairing, okay, we need pairing, and for pairing simply means that we need even number of nodes. Okay, even number of nodes, and we also know that these nodes, all the nodes are connected with each other, and like this. Okay, Ju and V, all the nodes are connected with each other, and we don't care about the in between number of nodes. Okay, so this is also we have to okay, so see here, U and V, okay, both are connected, and we are ignoring in between now, because all the nodes which are adjacent to each other in between are becoming by default comes to their original form. Okay, when we are performing the XOR operation. Okay, so here what we have to do here, okay, we have to get the output as 5, but we are getting as 6. Okay, so what I'm going to do here, originally this node value is 2, this node value is 1, this node value is 2. Okay, so if I was performing the XOR, okay, okay, so let me draw the diagram again. 1 2 2. Okay, 1 2 and 2. Okay, so see here, originally I should have get the result as 5, but when I am performing the XOR, then this number is changes to 2, and then this number is changes to 1. Okay, this is what's happening. This number changes to 2, and this number changes to 1, right? So here what I have to do here, what is the minimum loss? Here I have to find the minimum loss. Okay, total minimum loss when I am doing the XOR. Okay, total minimum loss when I am doing the XOR. Okay, so what is the minimum loss here? So for this node, value was 2. Okay, value was 2, and it is becoming 1, so 1 is the minimum loss. Okay, so I hope that this line is clear. Okay, minimum loss, what is the minimum loss that is happening? Okay, when I'm doing the XORing. Okay, so if I change, if I do the XOR of this one, right, I did the XOR of this one to 2. Okay, definitely I did the XOR of this one with some particular value, other value, right, because I am performing the XOR in edges na. So if I, let's suppose if I do the XOR of this one and this number becomes 2, definitely this number will be decremented. Okay, if I am performing the XOR, right, because I am doing the XORing in pairs na, every time I'm doing the XORing in pairs. So here if I did the XOR of this number, then this will become 2, right. Here I'm not writing 1 here in the output because I am ignoring it. But in general, if I'm doing the XOR, okay, if I'm doing the XOR of any particular node, then definitely I'm doing it with some other node, because in pairing I'm doing it, right. So if I am doing the XOR for this particular H, then this number will become 2 and this number will become 1. Okay, so this is the minimum loss. Okay, I have to retain the minimum loss. What is the minimum loss that is happening while performing the XOR? Okay, so this is the minimum loss that's happened here. Okay, minimum loss. Okay, this is the minimum loss that's happened here. Okay, so I have to just, this is my total result 6. In this 6 I have to just subtract minus 1, this one. Okay, and I have to give the output as 5. Okay, this is the minimum loss. Okay, so definitely I have to remove the minimum loss. Okay, so in this particular case we have just one odd number. Okay, but in case we have total, okay, in this particular case there is just one edge, there is just one node on which XOR value is updated. Okay, XOR value is updated. Okay, but in case if there are total 3 nodes for which we have updated the XOR value, okay, but this is also odd case. Okay, so we have to make it as 2 only, so we have to subtract one minimum loss. Okay, so every time I have to subtract one minimum loss. Okay, so now I'm going to explain this problem with this very important example. Okay, but before that let's write the code. Okay, then after that I am going to do the debugging. Okay, so this is my code. Okay, so let's zoom it. Okay, so here first of all we have to just write int total sum. Okay, so total sum is equal to 0. Okay, let's take it as long. Okay, because we have to return in long now. So, okay, total sum is equal to 0, and then also we have to calculate the nodes for which we are doing the XOR. Okay, so XOR beneficial count is equal to 0. Okay, so here we are going to keep track of the nodes for which are getting benefited by performing the XOR. Okay, and also we have to create one variable to store minimum loss. Okay, so initially let's pass the max value of integer. Okay, now we have to iterate over all the numbers one by one. Okay, so I'm going to use for each loop. Okay, so here let's perform the XOR first, XOR of this particular number. So XOR value for particular number num XOR with our k. Okay, and then I have to check if XORing the value increases it. Okay, if I'm doing the XOR and that XOR value is increased than the original number, only in that case I have to perform update the number. Okay, XOR value, if my XOR value is greater than my original number, okay, then in that case okay, then in that case I have to increment the count of this XOR beneficial count, right. So here I am just copy pasting this XOR beneficial count and I am incrementing it, and after that I have to update my total sum. Okay, so now my total sum will become total sum plus plus XOR value. Okay, so in total sum I am passing my XOR value. Okay, this is done. But if my XOR value is smaller than my original number, then in that case in total sum I have to just pass the original number. Okay, so I hope that this is clear. Okay, this piece of code is clear. Okay, also here one more thing, we have to track the minimum difference while when XORing. Okay, minimum difference. So for that, minimum loss, let's update the minimum loss. Okay, if I am performing the XOR, so let's keep track of the minimum loss that's happening step by step. So math dot min of, here write minimum loss and math dot absolute value of num minus XOR value. Okay, this is done, right? Now after that, just 2-3 lines are pending, right? So if, okay, now it's very simple. If the count of this XOR beneficial count, okay, the number of nodes in which we are doing the XOR is even, okay, if it is even, then simply return total sum. That's it. Then simply return this, return total sum. But otherwise, in the else part, if the count is odd, okay, then we have to return total sum minus minimum loss. Okay, minimum loss, whatever the minimum loss is there. Okay, that's it. Code is so simple, right? Just 24 lines hardly, right? So now let's run the code and see if there are any code issues. See, all the test cases has been accepted, right? All the test cases has been accepted. Okay, so now let's submit the code. So see, our solution is accepted and it beats 100% of users with Java. Okay, so we are iterating over each number one by one. Okay, so my time complexity is just going to be of n only. Okay, and space complexity, since we are taking constant values here, okay, so I'm going to say my space complexity is going to be of 1 only. Okay, so yeah, we are good, right? Time complexity is of n and space complexity is of 1. So now let's see, let's debug the code with this particular example. Okay, so initially I am going to iterate over all the nodes one by one. Okay, so 24, this is the node, this is the value for this particular index. Okay, so here I am going to write 24. This is a value for this particular node at this particular index. 78 is the value for the node at this index, one index, and 1 is the value for the node at second index. Okay, so here I am writing 1. 97 is the value for the node at 3 index, so here I am writing 97. And 44 is the value for the node at 4th index, so here I am writing 44. Okay, this is done. And also we are performing the XOR, okay, for all the numbers. So let's write the XOR as well. Okay, in green I am going to write the XOR of all numbers. Okay, 1 XOR 6, k value 6 now. So 1 XOR 6 is, let's check it, and 7. 1 XOR 6 is 7. Okay, 1 XOR 6 is 7. What is the XOR of, okay, 1 XOR 6? Here let me write it like this, 1 XOR 6 is equal to 7. Okay, what is the XOR of 78 with 6? 78 with 6 XOR value is 72. Okay, 72 is the value. XOR of 24 with 6 is 30. 24 XOR 6 is 30. What is the XOR of 44 with 6? 44 with 6 is 42. 44 with 6 is 42. And what is the XOR of 97 with 6? 97 with 6 XOR is 103. Okay, 103. 97 XOR 6 is equal to 103. Okay, so now here okay, so I hope that these lines are clear already, right? So we are going to iterate one by one over my nums arrays. Okay, so first we are going to do the XOR of this 24. So what is the XOR value of 24? Is 30, right? So XOR value 30 is greater than my 24, then my XOR beneficial count is incremented to 1. Okay, okay, that is right. From 24, okay, value is incremented to 30, and that is why my beneficial account is incremented to 1. Okay, and what is the total sum? So total sum will become 30. Okay, total sum becomes 30. So, okay, so here I am writing 30. Now let's plus. Okay, this is done. And minimum loss is equal to math.min of minimum loss, that is integer.max value, and absolute value. So what is the original value of nums? 24, and XOR value is 30. So minimum loss is 60. Okay, so in this case right now minimum loss is 6 only. Okay, so here I am writing 6. Okay, so here let's do one thing. Here write this is nothing but x b c XOR beneficial count, and this is nothing but my minimum loss at this point of time. Minimum loss. Okay, this is a minimum loss could happen if I'm using 24, okay, instead of 30. If I'm just using 24 instead of 30 without performing XOR, then this could be the minimum loss. Okay, okay, so here I'm just writing the minimum loss that could happen. Okay, minimum loss that could happen if I'm not going to do the XOR. Okay, so this is my minimum loss. Then after 24 we are performing the XOR of 78. So 78 value is decremented to 72, and there is no change in my XBC this time. XOR value is not greater than. Okay, so my total sum, I am just adding 72. In my total sum I am just adding my 72. Okay, so there is no change in XBC, so I am writing XBC as 1. Okay, there is no change, and this is nothing but minimum loss. So minimum loss is equal to, previous minimum loss was 6. Okay, 6 comma math dot absolute of 78 minus 72, 6. So what is the minimum between 6 and 6? 6 only. So here I am writing 6 only. Okay, this is the minimum loss that could occur till now. Okay, okay, this is clear, right? Minimum loss till now is 6 only. Okay, here I am maintaining the minimum loss. Okay, so now this is done. This is done. Okay, let's do one thing here. Let me move this, one second. Let me move this little down. Okay, this is done. Now after that we are going to check for 1. Okay, for 1 value is incremented. Okay, when I do the XOR, value is incremented to 7, and definitely my XBC count will be incremented to 2. And now this time minimum loss is 6, absolute value num is original value num is 1, minus 6 minus 7, so 6. So math dot mean between 6 is 6 only. Okay, so this is done. Okay, then after 1 497. Okay, I hope that things are getting clear side by side. 497, when I do the XOR, then this value is incremented to 103, and definitely my XBC count will be incremented to 3. And now minimum loss is nothing but 6 comma math dot absolute 97 minus 103 is nothing but 6 only. So it remains 6 only. This is the minimum loss. Okay, this is the minimum loss. Till now this is the minimum loss. Okay, now after that 444. Now see carefully. 444, when I do the XOR, my value is decremented. See, when I do the XOR of 44 with my case, that is 6, so value is decremented to 42. Okay, 42, and this time we have to just add the original value. We have to just add the original value. that is 44. Okay, so definitely there is no change inside this. Okay, so let me fill this as well now. 30 plus 72, and after 72 we are always adding the max value now. 72, and then we have to add 7. Then after that 97 103, but is the max 103. Okay, then after that 44 42, we are not going to add the XOR value this time. We are going to add the original value. Okay, just like in this case where we have added 78. Okay, so here I am adding 78 now, not 70, 72, 78. Okay, I have to add the original value now. Original value. If my XOR value is greater than num, only in that case I am adding the XOR value. Okay, so for this and for this particular case I am adding the original values 78 and 44. Okay, so let me add 44 as well, plus 44. Okay, so XBC count, there is no change, so it remains 3 here. And this minimum loss right now is, what is the minimum loss? So this value is 6, absolute value, original value 44 minus XOR value 42, so minimum loss is 2. Okay, minimum loss is 2. Okay, this is my minimum loss. Okay, so now let's perform the addition of all these numbers. Let's perform the addition of all these numbers. What is the total addition that I am getting? So 44 plus 30, 44 plus 30 plus 30, 30 plus 78 plus 07 plus 07 plus 103, 262. I am getting output as 262. 262. But 262 is wrong. Tell me why 262 is wrong. Okay, so see here. I am getting the output as 262. I am getting the output as 262. And this 262 is wrong. Okay, this 262 is wrong. Okay, our output, expected output should be 260. Okay, so what I am going to do here, see here, what is my XBC count? XBC count is odd. Okay, so if it is odd, then in total sum is 262 that I am getting, and minimum loss is 2, right? 262 minus 2 is 260. Okay, so I have to turn the minimum loss now, because I can't perform the XOR for odd number of times. Okay, so here I am doing the XOR for this node, for this node, and for this node. Okay, I am adding the sum of 3 XOR values. Okay, which is not right. I am adding the sum for 3 XOR nodes. Okay, so definitely I have to reduce the sum of one node. Okay, of one minimum loss. Okay, I definitely have to remove the minimum loss. Okay, so see here, for this 24. Okay, so 24 value is incremented to 30, right? For 78 value is decremented to 72. Okay, so this is clear, right? So here for node 44, okay, for this node 44 value is decremented to 42, and for 97 value is incremented to 106. Okay, so for this 2 and this, for this particular edge, okay, for these 2 nodes, okay, value is incremented. Okay, this is one case, this is one case. Okay, value is incremented here for both the nodes. Okay, in this particular edge, in this edge also I am incrementing the value of this one to 103. Then definitely I am also doing the XOR. If I am doing the XOR of this 97, I am definitely doing the XOR of this 44 as well, right? So why I have added the max value here? Why I have added a max value here? I should add 42 now. I should add 42 here. If I am adding the XOR of 97, that is 103, then I should add the XOR of this 44 here, not for okay, I have to add the XOR of 44, that is 42 here in the addition. Why am I adding 44? That is why in the end I am subtracting the minimum loss. Okay, minimum loss. Okay, because I have to return the maximum value. Okay, in the problem statement I have to return the maximum possible sum. Okay, so for returning the maximum possible sum I have to just subtract the minimum loss. Okay, I have to just subtract the minimum loss so that we can form the pairs. Okay, we can form the XOR in pairs only. Okay, so I hope that you guys are able to understand today's problem, and if you guys still have any doubts then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you, bye bye, and don't forget to like this video, share this video with your friends, and please subscribe to my YouTube channel. Thank you, bye bye.